This is 4.5 Rational Functions Day 2, where we will be graphing the rational functions. I have developed 5 steps for you, and the first step is to factor the numerator and the denominator. The second step is to find the x and the y-intercepts. The third step is to not only find the vertical asymptotes, but also to determine the behavior of the graph on each side of the asymptote. And the behavior is, if you remember from day 1, when we had x as approaching the vertical asymptote from the left, and we put a little negative sign up on the number, or we had x is approaching the vertical asymptote, whatever number that is, with a little plus sign showing you that it's on the right-hand side. So to determine the behavior, we are going to add and subtract 0.1 from the value of the vertical asymptote, and we are going to plug that into the function, the rational function, to determine a positive or a negative value. A positive value would mean that y is approaching positive infinity. A negative value would mean that y is approaching negative infinity. And so a lot more to do there than just finding a vertical asymptote. For the horizontal asymptote, same thing that we did in day 1. And I'm going to put this little added information in here, which is actually from day 3. But if the numerator degree is larger than the denominator degree by 1, then you will end up finding a slant asymptote, which is what we're doing in day 3. But then all these steps can be followed no matter what you're doing, whichever rational function you're doing. So now number 5, you're going to identify some additional ordered pairs to help shape the graph if you need to. And sometimes you might need an extra point or so in on the coordinate plane to be able to graph your function. All right, so let's look at this example. We are going to graph the rational function. We have r of x equals 2x squared plus 7x minus 4 over x squared plus x minus 3. So we need to factor that. And to factor that, you could use the product sum rule or quad 3 on your calculator or the diamond method. So if you don't know how to factor, if you don't have quad 3, then you need to make sure you figure that out because you don't need to be stuck at this point because there's a lot more to do. We've already been doing factoring of quadratics, so that's something that we need to have figured out by now. So let's go and factor this. When we factor, we get 2x plus 1, 2x minus 1, my bad. 2x minus 1 times x plus 4 over x minus 1 and x plus 2. Okay, so that's step 1. Second step, we are going to find the x-intercepts and the y-intercepts. The x-intercepts, if you remember, is setting this whole rational function equal to 0, which means the numerator is going to be 0. Since we have 2 factors in the numerator, we will set each factor equal to 0 and then solve. So to solve 2x minus 1 equals 0, you get 2x equals 1, divide by 2, and you get x equals 1/2. And then for x plus 4, you're going to subtract the 4 and get x equals negative 4. So those are your x-intercepts. For the y-intercept, you're plugging in 0. And I'm going to plug into the original function. So 0. Remember that anytime you have an x term, that value is going to end up being 0 because you're doing multiplication. So 0 plus 0 minus 4 over 0 plus 0 minus 2. So we're looking at negative 4 over negative 2, which is y equals 2. So we've got our x-intercepts and our y-intercepts. Okay, let's look at our third step, which is finding the vertical asymptotes. And for the vertical asymptotes, we are setting the denominator equal to 0. The denominator factors were x minus 1 and x plus 2. So our vertical asymptotes are at x equal 1 and x equals negative 2. So those are the vertical asymptotes. I'm going to put those in boxes instead of circles just so I can keep straight. Now I need to do my behavior of the graph. So as I stated before in the steps, you're going to add and subtract 0.1 to each of these. So if I add 0.1 to 1.1, I'm going to get 1.1. Sorry. If I add 0.1 to 1, I get 1.1. If I subtract, I get 0.9. If I add zero point 0.1 to negative 2 and then also subtract, I will get negative 2.1 and negative 1.9. So I'm just 0.1 away from our vertical asymptotes. So now I'm going to do my testing. I'll go from left to right. So I'm going to start with negative 2.1. And you could plug that into the original rational function, or you could plug that into the factored form. If you plug into the original rational function, you'll have 2 times negative 2.1 squared plus 7 times negative 2.1 minus 4. And then you're going to divide by the entire polynomial of the denominator. So what you need to do is, if you're doing this on your calculator, you need to make sure you put a parentheses around the entire polynomial. Okay, and so you're going to also then put negative 2.1 in parentheses. Anytime you do a negative number in parentheses, make sure you do, or I'm sorry, anytime you do a negative number to with an exponent, make sure you put it in parentheses. So like I have it written here, you want to see it on your calculator just the same way I have it written here. But you want to have this extra parenthesis for the denominator. So negative 2.1 squared plus negative 2.1 and then minus 2. And then end with another parenthesis. So if you plug that into your calculator, you will have a positive or a negative number, and then you're done. Now, if you don't want to just rely on your calculator, I would plug negative 2.1 into the factored form. So if I do that, I have 2 times negative 2.1 minus 1 times negative 2.1 plus 4 over negative 2.1 minus 1 times negative 2.1 plus 2. Okay? And now what I'm looking for when I do this is the value of each factor. Is it positive or is it negative? So when I multiplied 2 times negative 2.1, that's negative 4.2, minus 1 is negative 5.2. So that's a negative number. Negative 2.1 plus 4 is going to be a positive number because the positive number was a larger value than the negative number. Negative 2.1 minus 2 is a negative number, and negative 2.1 plus 2 is negative. Again, because the negative number here was a larger value than the positive. Okay? So then, when we look at this, we look at our negatives. We have 3 negatives. When you multiply and or divide by 3 negative numbers, your final outcome is a negative number. Okay? So at negative 2.1, I will have a negative value. So my y is approaching negative infinity. So I would write as x approaches negative 2. Okay, negative 2.1 is on the left-hand side of negative 2. So I'm going to put a negative up here. So as x approaches negative 2 from the left, y is approaching negative infinity. Okay? So I'm going to do that kind of a test for each of these points. I know it's a lot of work. So here we do, now I'm going to do negative 1.9. I'm not going to go through it quite as detailed as I did here, but I will write out starting with my factored form. So negative 1.9 times the 2 minus 1, negative 1.9 plus 4 over negative 1.9 minus 1 times negative 1.9 plus 2. So here I'm going to have a negative number. Negative 1.9 plus 4 is positive. Negative 1.9 minus 1 is negative. Negative 1.9 plus 2 is positive. So two negatives is a positive outcome. So as x approaches negative 2, now we're on the right-hand side of that negative 2, so we're going to put plus up on there. So as x approaches negative 2 from the right, y is approaching positive infinity. Okay? Now we test 0.9. So 2 times 0.9 minus 1 times 0.9 plus 4 over 0.9 minus 1 times 0.9 plus 2. So here we're going to get 1.8 minus 1, which is a positive number. 0.9 plus 4 is positive. 0.9 minus 1 is a negative. 0.9 plus 2 is a positive. So we only have one negative, which is a negative number. So as x approaches 1, we're on the left side of the asymptote right now. So from the left, y approaches negative infinity. And finally, 1.1. So 2 times 1.1 minus 1 times 1.1 plus 9, or 4, sorry, over 1.1 minus 1 times 1.1 plus 2. So for the first factor, we're going to positive. 1.1 plus 4 is positive. 1.1 minus 1 is positive. 1.1 plus 2 is positive. All positives is a positive. So as x approaches 1 from the right, positive. So because 1.1 is to the right of 1, y is approaching positive infinity. Okay, so we've got all that. We got to keep that in mind here when we do our graph. So now step number 4 is the horizontal asymptote. And the horizontal asymptote is based on the degree of each of these. Since n is equal to m, they are both x squared. We are looking at the leading coefficients, 2 over 1. So y is equal to 2 over 1, which means y is equal to 2, is our horizontal asymptote. So before I do step number 5, I'm going to put my asymptotes on here and have that before to be able to tell me if I have the information I need. You know, I plot all my points and things like that. So I'm going to choose red. All right, so I had a vertical asymptote at 1. I'll move that here in a minute. And negative 2. And a horizontal at y equals 2. Okay, so let me adjust these a little bit. Make this one a little bit longer here. So this one, I'm going to move to the right here. Now I'm at -2. This one goes over to 1. And this one could go down just a little bit. Sorry. Okay, so those are my asymptotes. So based on my behavior over here, I could actually plug in or just make a little notation for my graphing. So at -2.1, I was down here at -infinity. So I could just put some kind of marking here. I'm going to put -infinity. All right. At -1.9, I was positive. So I'm going to put a positive infinity up there. At 0.9, let's go down and check that. At 0.9 now is negative. So down here at -infinity. And then at 1.1, I was positive. So I'm going to put that up there. So I know now that as I'm approaching the asymptote from the left, I'm going to be going down. So whether it be up here, however, I'm going to be going down. Okay, let's plot our x and y intercepts. So our x-intercept is at 1/2 right here. Another one at -4. 1, 2, 3, 4. And we have a y-intercept at 2. Okay. When we look at this graph, I can see I've got a point here on the left. And the thing to know about rational functions is you will have some kind of a graph in each of the sections divided by the asymptotes, the vertical asymptotes. So I'm going to have some kind of graph here on the left, some kind of a graph here in the middle, and some kind of a graph here on the right. And if I look at this, I have no points whatsoever over here on the right. So I'm going to need to choose a value of x to plug in to find an ordered pair. So if I go over here, I could choose 2 or 3. Okay, for no reason, I just chose x equal 3. So I'm going to find um, when x equals 3. So 2 times 3 minus 1 times 3 plus 4 over 3 minus 1 times 3 plus 2. Okay, that's 6 minus 1 is 5 times 7 over 3 minus 1 is 2 times 5. So 35 over 10, which is 3 and 1/2. So if I go over to 3, 1, 2, 3, I'm up at 3.5, which is about right there. Okay, so now if I look at when I look at my graph here, I can see that my graphing is going to be down below the horizontal asymptote because not only am I going through a point below the asymptote, but then as I get close to the vertical asymptote, I'm going to -infinity. So from this, I really do have enough information to give myself an idea that this graph is going down like that. Okay? So it's going from x equal to -infinity. It's coming closer and closer, closer through my x-intercept and then down. Okay? In the middle, I'm starting here close to the asymptote at +infinity, and I'm ending at -infinity down here. And I got to make sure I go through these points. So I'm going to be going down, and it's going to curve over, go down through, and then be guided by the asymptote. Okay, so it's that S curve kind of look. Over here, I'm coming from +infinity when I'm close to the asymptote, and then I'm going to go through this point and then continue on to x equals +infinity. So I'm going to go down and go through that point and then be guided by the asymptote. And now I have my graph. Okay, so you're plotting your points You find another point if you need to, and then you use those points and the asymptotes to guide your graph. Okay? And now we're done.